Hello everyone. In this third video of mechatronics, we are going to look at digital read and serial input and baud rate. The picture here, these pictures are taken from this documentation page on Arduino, so they don't belong to me. And although this is a very simple program, there are a few important things that are missing in the explanations, and I'm focusing mostly on those. So as you know, the Arduino has a bunch of digital pins that you can basically use as input or output. Last time with LED we used them as output. We send the high and low signal with some frequency and we made it blink. This time we're going to read digital signal in, and for that we are going to basically use a push button. So here we have this push button, and it has 4 legs. Each 2 of them are basically the same, connected. So these two legs here on the right, they are basically the same. These 2 on the left, they are the same. And in order to connect them to each other, what we can do is to press. Okay, so if we press, they are going to be connected together. It's just a push button like you can see here. So if you're not pressed, it's closed. If you press it, you're going to close the circuit, and the circuit is going to be on. So now you can see that this one of the legs of this push button is connected to high voltage 5. The other one is connected to pin 2, so we're going to use pin 2. Now in this case, I'm not going to use pin 2, I'm going to use pin 12 instead. So it is actually going to go here, but I'm going to connect it to one of the input pins to read it as digital read. And then you also see that this end that is connected to the pin, it's also connected by a 10K resistor to the ground. So what is this portion about? If all I need is to receive 5 volts from pin 12, or if the circuit is open, no volts or 0 volts from there, why do I have to connect the other end of the circuit to the ground by a 10K resistor? What is this portion for, and why 10K resistor out of all these different resistors? Okay, so here there are some things that we need to discuss. And so if I just look at the sketch or the program, you see I defined push button as pin 12. In my setup, I said the push button pin mode is input, so I'm reading the signal from it. The other thing I want to do here, every time I press on this push button, which you can see here, right, that push button, anytime I press it, I want it to show something so I know it's pressed. So I'm going to show on the serial monitor here, right, which you can click on this guy and bring the serial monitor. I want to type in the serial monitor, say key pressed. So anytime I press, I want this text to be shown. Now, since it's a serial monitor and serial communication, you have to tell it when you are sending this bit information, you have to tell it how fast these information are being sent to the serial monitor. So here you provide the speed of the information transfer, which is called bits per second, or baud rate, and you're saying 9600 bits per second is how fast I want the serial communication to start. So this is setting up the speed of the communication. And when you do that, here in the serial monitor, you have to set the same number as you did in the code. If here I use 9600, here also in the serial monitor I should use the same baud rate, otherwise you're going to see what's going to happen to this text. So what do I say here in the loop? I say I define the variable push button. This is what I read from the push button using the command digital read, and it's a state of that push button whether it's high or low. And I say if it's high, if it's pressed, then show that text on the serial monitor. And then here I add some delay, and I'll explain why I add this delay and this second delay. Especially this one is important in the loop inside this if. and you'll see why I added that delay here. So basically that's all I'm doing, reading the digital. Pin number 12, if the key is pressed, is high, it shows key pressed. If it's low, nothing is going to be shown. That's all it is. So first, let's see the performance of this. So here, I'm going to press on this key and look what happens. You see? Look at the serial monitor. Key pressed, key pressed, key pressed. Every time I click, one of that text is shown. Okay? Yep. Now, let's go back so I can explain some extra thing here. One, let's talk about the baud rate, that 9600. So what's special about the baud rate? Well, first, as I said, this is the speed of the communication. And it's not always the bit per second. Most of the time it's the symbol per second. Now many times the symbols that you consider in serial communication are the same as bits, so it is going to be bits rate or bits per second. Okay? And there are all sorts of baud rates or bit rates available. There are 9600, less than 9600, all the way to 115,000, right? So if you go here, you see you can start from 300 all the way to even more. Like if you look at this guy, you can even for serial monitor, you can go up to 2 million. Okay, so there is a huge range of baud rates that your serial monitor can support. But does your Arduino Uno also support all of those baud rates? The answer is no. Not all of the baud rates that you have here in the serial monitor are supported by the Arduino. Arduino does not support all of them. It supports some of them. For instance, typically the maximum it supports is up to 115,000, not all the way to 2 million. Okay? So it supports a bunch of rates. That's the first thing. Now, one thing is, if the serial monitor and your code are not synchronized, so here I use one number, but in my serial monitor I use a different number. What's going to happen when I press the key? Look at what happens. You see, now your text is going to be basically garbled. You cannot understand it because the text that I'm sending, the rate I'm sending and the rate I'm receiving and decoding are not the same, so clearly I don't see anything meaningful coming out. And it goes for both ways. Whether you go higher or lower here, it doesn't really change the fact that you cannot read it. Of course, it's going to be different text, but clearly you cannot read that. You can only read it when you are at the same baud rate as your Arduino code. Okay, then you start getting good things here. Look. So now I'm back to key pressed. So that's the first thing, that they have to be synced. Second, out of all these numbers, where does 9600 come from? Well, 9600 in general is the one that is suggested for general debugging. So if you're writing some code and you want to debug it and make sure it is working, the best baud rate typically suggested is 9600 because it's first of all widely supported. Most of the hardware and software support that, and it's stable. Okay, by stable, what does it mean? For instance, if you go for higher rates like 115, this is really good. This is when the code is all debugged and working. You want high speed communication, but if some of the data is lost because you're communicating so fast, so the data cannot be decoded that fast and displayed, if you lose some of the information, you don't care too much about it. Okay? So you have to pay attention. The faster you do it, your hardware or your software cannot basically catch up, and you might start losing some data. So if you don't want to lose any data and you want stable communication, which is whatever you send exactly you receive and show, then or use, then you better go with something that is not super slow but extremely not super fast. So this is a good balance point, 9600. Good. So this is one portion of it that I wanted to explain. The other portion of this that we need to explain is basically the circuit that I mentioned here, this portion. So what about this portion? So what is this circuit here, and what is this resistor, and why should it be 10K? So this guy here is called a pull-down resistor. And that circuit is to do a pull-down operation. What is that? Well, let me explain this part. So, let me move this out of the way. So, if you don't have that portion, okay? So you don't have that portion altogether, and all you have is this top portion. Okay? Right? Now, here, if the circuit becomes open, you have not pressed the push button, it's open. What do you think this pin is going to read? You might say, well, of course the circuit is open, it's going to read 0. The matter of fact is, it's not going to read 0. It is going to be, that pin right now is going to be called, the input to that pin is called floating. What does that floating means? It means that pin is not connected to anywhere. That pin, when this guy is not there, and that circuit is open, this pin is basically connected to nothing. It's dangling, it's up in the air, it's not connected to anything. So the number that it would read is not necessarily 0. It can pick the noise from surrounding equipment, and it can show some variable numbers, small numbers, and it can change randomly and erratically, as opposed to show a 0. So to make sure that when that circuit is open, it exactly shows 0, I'm going to connect it to 0 voltage. I'm going to connect it to the ground by this other circuit. Now I make sure, even if this circuit is open, this guy is connected to the ground so it can show the low voltage. Okay, so that's why I have this other circuit, to make sure it shows low voltage. But what is this resistor for? Well, clearly when the circuit is open and this bottom circuit is running, if this pin picks any small voltage from noise from other surrounding equipment or electronics, there will be some current in this circuit. But when there is resistor, it is going to damp that current very fast and bring it down, right? Because these wires, naturally, they don't have too much resistance. But if you add a resistance here based on the Ohm's law, the total resistance is going to go up. So the current is going to be so low that basically it's not going to show anything on this pin. And it is going to be basically reduced significantly by this resistor. Now, the thing is, why 10K out of all these values? 10K is good for what? Well, 10K provides a balance again between what and what? It provides a balance between a good response time and keeping the power usage reasonable. So if I use a smaller resistance than this one, like a 1K instead of a 10K, what would happen? When the key is pressed and the circuit goes high voltage, okay, then some of that current will come through this as well. And if this is low resistance, this circuit is going to get more current into it, which is not what I want to have, okay, because it is going to go to the ground. I want it to go to the pin 2. So I should not make this super low resistance so that this branch can take a bunch of current out of pin 2. So it should not be really low, because then, as I said, it draws more current out of it. And when it does, in applications that are running by battery and your power is limited, it is going to deplete the battery very fast. On the other hand, if I make this guy very large, like make it 100K instead, then what happens? If I make this very large, then it brings down the current that is going into this pin when the circuit is open. Now look at the scenario when the circuit is open. When the circuit is open, ideally, this one should show low, as I said. Now when this guy is very large, this one is picking random noise, and if this one is very, very large, the current going through this is so small, almost close to zero, that it cannot even tell this pin that, hey, pin, the current coming through you is very, very small, consider it low and show low. Actually, the reason is these pins of the Arduino, they have a very, very large impedance. So Arduino digital input pins, they have very large impedance, and if you get very, very tiny currents by large resistor there, then you might not even, the current going through it might not be high enough to fully pull that pin to low. Now that is super small that it cannot even force this pin to show a low. There are always thresholds here, okay? So there are thresholds above which we go high, below which we go low. And if this is super small, it might not even be good enough to show a low over there. So we have to have a balance here, okay? We have to have a balance. Very large thing will make that current so small, and it takes some time for this high impedance pin to show that it was low, so you're going to get a bad response time as well. On the other hand, you make it so small, you're going to use a lot of power. So 10K is a good balance between these two, and that's why we use 10K. Now we call it a pull down resistor because it forces this pin to show 0 voltage, because it connects that pin to the low voltage, to the ground. So it's called a pull down resistor. It connects it to a down voltage, to a low voltage. If on the other hand, my pin was, basically switch was here, right? And this resistor was up there connecting my pin to the high voltage. So whenever the circuit is open, the pin 2 is connected by resistor to the high voltage. So whenever circuit is open, instead this pin shows a high. Why? Because it is attached to the high voltage. Then we call that resistor, we call it pull up resistor. Okay, so a pull up resistor is a resistor that will ensure your pin gets a high when the circuit is open. But a pull down resistor will make sure your pin shows a low when you have the circuit open through the push button. So that is the difference between a pull up resistor and a pull down resistor. Basically, they connect your pin to the low or they connect your pin to the high. And why you would use them, and why you would use a 10K, and what is baud rate. So all of them I could discuss for you in this short video. And again, you clearly can see that your circuit is the way it is shown here. Here I turned the light off. I don't know if you can see it better or not, but basically this is your sketch, and this is your what? This is your serial monitor, which you can see it shows key pressed. So hopefully this video was useful to you. You learned some explanations of what is baud rate, what is pull up, pull down resistor, and I'll see you in the next lecture. Thank you.